Alright, so today we're working with section 1.5 angle relationships. This is a day where these notes take quite a bit of time, so it's one of those things where you can go through on your own pace and really copy down a lot of notes. These are the terms that we're going to work with today. We're going to define these, and then I'll go through some examples. So an angle relationship on the back, we put this on the back of our foldable notes here, and we would talk about perpendicular lines. So perpendicular lines, we can draw these. This is an example of perpendicular lines, and that forms a lot of things. So how do we represent perpendicular lines? So they intersect to form four right angles. So the first thing you do is you'd mark that. That tells us we now have a right angle, and we now would know from this definition we have perpendicular lines. We know that if we have perpendicular lines, they intersect to form congruent adjacent angles. So we're going to go through what adjacent is today. Adjacent means they're right next to each other. So these are right next to each other. They're congruent. They're all 90. And we have that symbol to represent that. Square in the corner of the two lines symbolizes that the lines are perpendicular. So first thing we want to talk about here is what is adjacent. Two angles that are side by side. They share a common vertex, and they share a common side. So example right here, angle 1 and angle 2 are called adjacent angles. Here's their common vertex. They share that common line, and they have their own separate angles. Common vertex is here, and there's your common side. So if we go to the right over here, when it says this is not a non-example, and here's why. Because angle 1 is right here. This is angle 1. Angle 2 in this example is going to be that. So that's angle 2. Why are those not adjacent? Well, even though they share the common vertex, they don't share the common middle side. They have to share a common middle side. So you might say, well, they share this side, but you see that angle 1 makes up or is part of angle 2. So that means it's added into it. That means they are not adjacent. Adjacent means next to it. This is a non-example right here because angle 3 is here, angle 4 is here. They have no common vertex. So this one right here, this was not side by side, so you can see that. And this one has no common vertex. This is a vertex, this is a vertex, not common. The definition of adjacent. Next one we talk about is vertical. Vertical angles have two non-adjacent, so that means they're not next to each other. So in this example, these two are adjacent, which means they are not vertical. These two would represent adjacent angles. Vertical angles are formed by two intersecting lines. They have a common vertex, no common sides, and now we will know that vertical angles pairs are congruent. So let's look at the example. So we just sketched two lines like this. Here's angle 1 is congruent and vertical with angle 2. They share the common vertex right here. They're across. I like to say across from each other. Here you go. In this example, we also have angle 3 and angle 4 are vertical angles. They're across from each other. They share the common vertex, and they are also congruent. Why is this a non-example right here? This is not a straight line with this, so therefore those are not equal. Straight line like this. They are not straight, so there's a non-example. Next definition is what's called a linear pair. Linear pair, first of all, two adjacent angles. The non-common sides form a line, and a linear pair sum is 180. So a lot of information. So here's our example that is a true and good example. You can see the straight line right here. We have their adjacent, so they share that common side, common vertex here. The non-common sides form a line. So this is a line, non-common sides, and those two will add up to 180. So a measure of angle 1 plus a measure of angle 2 equals 180 degrees. Our non-example is similar to what we did before, not adjacent. Even though 90 plus 90 equals 180, they're not adjacent angles. So that's a linear pair. Now complementary. Complementary angles are two angles whose measure equals 90, may or may not share a common vertex or side. So this example right here, you can see the 90-degree square. You can see here's angle 1, here's angle 2. They add up to 90 degrees. These two are adjacent, but it doesn't matter. In this example, we have 40 plus 50 adds up to 90. So yes, those are called complementary. Why is this a non-example? It's only one angle and not two. Non-example. Right here we have supplementary angles, similar to complementary, two angles whose measures in this case though is 180 instead of 90, supplementary 180, and again may or may not share a vertex or side. So this example, yes, that's 90, 90 plus 90 is 180, 120 plus 60 is 180. This is a straight line that adds up to 180. Those are all good examples of supplementary angles. Why is this a non-example? It's one angle. It's one angle. So now let's go through some examples, see if we can interpret and try to make some decisions here. So question A, two angles that form a linear pair. So again, go back to your definition. What's our definition of a linear pair? So look that up again. If you don't know, look it up. And then let's review a linear pair. So I'm going to give you an angle V. So V, Z, Y. So I'm going to use this angle right here. What makes a linear pair with that? In this case, V, Z, X. So two angles that share this side and that add up to 180. And there are a lot more examples that you can use in this case. So those are all good examples for linear pairs. You can pause that if you need. The next example here says two acute vertical. So again, look up your definition of vertical. What is a vertical angle? Angle less than 90 degrees. So, acute is less than 90 degrees. Vertical, basically I like to use the term across from each other. So I can see that 65 and 65 are across. They are formed by those two straight lines. So those two, now again, you can't use the numbers, so we would use angle V, angle Z, and angle Y. So that's what you would say is congruent with angle XZW. Those are two acute vertical angles. A couple more examples here to take a look and see what we have. So they want us to find X. So up here, they want us to find X. So KO is perpendicular. That's that symbol with HM. So KO, let's find here's KO, is perpendicular with HM. So if we want those to be perpendicular, we have to find X. Well, what do perpendicular lines form? They form 90-degree angles. So you're going to take these two right here. That's 90 degrees. We have to do a little algebra, set up an equation. So 3x plus 6 plus 9x equals 90. So again, it wants you to find x, so they are perpendicular. So to be perpendicular, those two have to add up to 90. So this is 11x plus 6 equals 90. Subtract over the 6. So 11x equals 84. And we divide by 11, and we find that x is 7. So I think it said to find x. Yes, so x is 7. And we'll come back to that here in a minute. And then question number 3 says, what is the measure of angle HJO? So right here, what is HJO? Well, again, has to be 90 degrees if they are perpendicular lines. Question number 4 says, what is the measure of angle MJN? So what is the measure of angle MJN? So that is also going to be, MJN is right here. So MJN is not MJO. So what do you notice right here? This and this are called vertical angles. So we know that it equals 9x. So are we done? Nope, we know the value for x is 7, so we're going to go 9 times 7. So we know that that is a 63-degree angle. 63. Last slide here, folks, is naming of some of these things. So I'm going to go through this quickly. You can pause and go through. Name the angle pairs. So what do you call angle 1 and angle 2? So again, refer back to your definitions. We know that these are adjacent, adjacent angles, and they are also complementary angles, adjacent and complementary. 1 and 5, what do we call 1 and 5? Those are called vertical angles. Now let's look at 2 and 3. 2 is here, 3 is here. Again, these are adjacent and complementary. Again, how do we know it's complementary? Because of the 90-degree square here. 90 degree, this is a 90-degree square. This is a straight line. So this has to be 90 degrees as well. That's where we get the complementary from. Let me try to clear this out a little bit best I can. So now they want the measure of, or what are they, the relationship between 1, here's 1 and here's 6. So 1 and 6 is adjacent. In this case, it's supplementary because it's a straight line, it's 180. And yes, it's a linear pair. Next we go to 3 and 4. Here's 3 and here's 4. Again, adjacent and complementary. And that's not always the case, but again, in this example here, 3 and 4, you have to go to the opposite here. You see that this is 90, and we need that's 90 because this is a straight line. Last one here is 4 and 5, and you can see that one's easier because it's already in the square. So adjacent and complementary. Finish up with some perpendicular lines, form the 4 right angles. You can see what that looks like and how we interpret that. And again, great job with the notes. Thank you.